we're going to continue with factoring today. So a couple of reminders. If you were told to factor and you see something that looks like this. If you see something like this, 3x squared minus 12x. What would you think to do? So I haven't been real clear on this, so we'll make sure I am now. Anytime you're told to factor, the very first thing you're always going to look for from here on out is your greatest common factor. Does every term have a common factor? Okay. In this problem, we only have two terms. We have 3x to the second power, and we have a negative 12x. So what common factors do they have? In other words, what are they both divisible by? 3. What else is with each term? An x. So we're going to factor out a 3x. And so to find out what's left, we just divide both of these terms by 3x. Okay. So when I divide that first term, 3x squared divided by 3x, the 3 divided by 3 is just 1. X squared divided by x is just x. Okay. And then the negative 12x divided by 3x, the x's are just 1. So x divided by x is just 1. So then negative 12 divided by 3 is just minus 4. And so every time, what you're going to do first is look for greatest common factor. Okay. All right. Let's get another example here. So this one we're going to factor. What's the first thing we're supposed to do? First thing we're going to do is look for greatest common factor. Okay, I now have 3 terms. Okay, do you notice anything that looks like it will go into all 3 terms? 2. They're all even. Okay, so the first thing I'm going to do is factor out that 2. I'm going to divide everything by 2. So that 2 just cancels out and left with x squared. 6x divided by 2 is just 3x. And 4 divided by 2 is just 2. Right. Now, inside the parentheses, we now have that trinomial that we can factor. Okay, so what my final answer is going to end up looking like is I'm going to have the 2 on the outside, and then I'm going to have the 2 sets of parentheses that I'm factoring out on the inside. Okay, so I've already factored out that 2. So now we can do that box, and this is a pretty simple one. So we'll kind of go through that process pretty quickly. We have x squared in the first box, and 2 in the last box. And again, this trinomial should be pretty simple, so the process may go a little bit quicker. Okay, if I multiply those together, it's just 2x squared, and there's only 2 factors, x squared, or x and 2x, which is good because we needed to add up to 3x. And it does. I know I'm kind of going through, so for those of y'all that struggle to keep up, make sure you slow me down if you need. Okay, so where do these two things go? These two spots? There you go. So the x and the 2x go in those other two empty spots in the box. And this is where we start looking at each row and each column and trying to figure out what factors they have in common. So we look at this bottom row first. What do the terms x and 2 have in common? 1. Yeah. The only factor those two terms have in common is a 1. Okay, that top row, x squared and 2x. The only thing they have in common is an x. That's going to be the same thing on this first column, x squared and x. And then hopefully you can see this one is a 2. So in my parentheses are now x plus 1. Plus 2. There's my factor. Okay. So I started out by factoring the greatest common factor out. And then I went into the box method. Let's look at this one here. So the next one's 4x squared plus 12x plus 9. So my first step is always look for a greatest common factor. So does 4, 12, and 9 have a common factor? Yeah, the only common factor they've got is 1. So I don't have anything to factor out. Okay, so I'm just going to go straight to the box method on this one. So we got 4x squared in that box and 9 in that box. What's the next step? Multiply these two together. Okay, so 4x squared times 9 is 36x squared. Okay. And so then I'm going to go through the factors. X and 36x, 2x and 18x, 3x and 12x, 4x and 9x, 6x and 6x. Again, if you struggle with the factors, you will have a calculator available. Just go through the dividing. I know that's still a struggle for a lot of us, so I don't want you to miss any because you weren't sure of the factors. Okay. So which pair of those factors adds up to the 12x in the middle? 6x. Yeah, 6x and 6x. So hopefully you'll notice these factors are going to be very similar. The common factor between 6x and 9 is a 3. The common factor between the 4x squared and the 6x, the 2x. And hopefully you notice that the columns are exactly the same as the rows. So my factors, 2x plus 3 times 2x plus 3. So, quick question on this last part. Can we make this a little bit shorter instead of writing that whole thing out like that? Can we make this last piece a little bit shorter? Yeah, anytime you take something and multiply it by itself, it's that something squared. So the squared's on the outside of the parentheses. We're multiplying 2x plus 3 times itself. Okay. So the official answer is 2x plus 3 quantity squared. So the parentheses squared. Now I want you to see something here real quick. So the different things that I highlighted there, what can you tell me about those?
They all have something in common.
Okay. What do you have to do to the 4x squared to get 2x?
One, five, two.
It's actually dividing it by 2x. In other words, if you take 2x times 2x, you get 4x squared.
Yeah.
If you take 3 times 3, you get 9. Okay? So what this is called, and I wrote it up here, this is called a perfect square trinomial. So if you recognize perfect squares, what are perfect squares? Number 1, because 1 times 1 is 1. Number 4, because 2 times 2 is 4. Number 9, because 3 times 3 is 9. So what'll be the next one? Well, what's 4 times 4? 16. What's 5 times 5? 25. So those numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 256, 425. I've jumped over somewhere. But those are all perfect squares. If this first term is a perfect square and this last term is a perfect square, there's a really good chance it's going to look like this at the end. Okay, where you have the quantity squared piece. Okay. So that's what's called a perfect square trinomial. It's very useful in pre-calc if you get to that point. But for what we're doing, going through the box method so that we're doing everything just alike is perfectly okay. So just notice that at the end you'll recognize this will be a perfect square. All right. Okay, let's do another one here. So this one that we're going to factor is x squared minus 64. Okay. So kind of thinking back to our standard form where we have ax squared plus bx plus c. What's our b here? 0. Because there's no x term. 64, negative 64 would be the c. Okay. So let's go through the box method and talk about it. In our box method, what would go in that first box? X squared. Okay. Where would the negative 64 go? Or does it? That goes in that last box. Because that's that C term. Okay? So then I multiply these out and I get negative 64x squared. So if this is a negative, that means one of my factors has to be positive. One of them has to be negative. But what do they have to add up to? They have to add up to 0. So the only way I can do that is if my factors are the same number with opposite signs. So 64, I told you a while ago, is a perfect square. So what's the square root of 64? 8. So my factors are going to be 8x and negative 8x. Hey, y'all, keep watching. I'll show you a shortcut on this in just a second. Just want to see it. Up here, x squared and 8x. What's our common factor? X. Okay. Negative 8x and negative 64. What's a common factor? I'm going to leave it with the negative because the negative's over here. So it'll be a negative 8. Okay, in this column here, x squared and negative 8x. Still again, just x. And then this 8x and this 64 will be the positive 8 because of the x term being positive. So my factors are x minus 8, x plus 8. Right. So back again like we had a while ago, what are some things I noticed? If I take those two terms and multiply them together, what do I get? If I take those two terms and multiply them together, I get that. Okay. So if you notice, x squared is a perfect square because it's x times x. 64 is a perfect square because it's 8 times 8. And there's a minus sign between them. That is something we call the difference of two squares. Okay? And it's kind of something it's kind of a little trick, but it's something that if you notice, it makes the process a little bit quicker. It's referred to as the difference of two squares. Okay, so in this case, the difference of two squares, the squares were x squared and 64, and the word difference just refers to the minus sign. Okay, so when that happens, when you have this kind of situation with x squared minus 64, or 81's thrown in there, or 25, or 4, then you take the square root of each. So the square root of x squared is just x. You put it at the front. You take the square root of 64, which is 8, put it at the back, make one on minus and one on plus, and you got your factors. Now, you don't have to go through the box method, okay, if you could recognize that quickly. Okay. Again, the box method works. So those of y'all that like to have one method that just works every time, follow that. All right. Let's do a couple more to kind of show the process to be a little bit quicker. This one's going to be 4a squared minus 49. First question, are there any common factors we can factor out of both terms? Yeah, the only one is the number 1. Okay, so there's no reason to factor out of 1. Okay, so now look at the two terms. There's a minus sign, so that could be part of our clue. Is 4 a perfect square? Yeah, because the square root of 4 is 2. Is a squared a perfect square? Yes, because the square root of a squared is a. Okay, because a times a is a squared. Is 49 a perfect square? Yes, what's the square root of 49? 7. Okay, so this is a difference of two squares. So I take the square root of the 4a squared, which is 2a, That goes in the front of both parentheses. I take the square root of the 49, which is 7. That goes in the back of both parentheses. And then you just put opposite signs in each of them. So make one of them positive, one of them minus. It doesn't matter if the minus comes first or second, as long as there's one of each. Okay. You okay with that? What questions do you have? So for the rest of the class period, you can finish up this. So just page 260, 37 through 45. There are 9 problems there. And so they'll mostly center around what we've done today, but they may not all be all of it. So use what you've had in the past to kind of help figure that out too. And we'll get this turned in. If you get it done by the end of the class period, it'd be great. You still got 20 minutes, so you should be able to get most of it done if you don't. And then we'll do some more practice over the whole thing tomorrow.